SpaceX manufacturing. Hook opening Boeing's Starliner. Still grounded after a full year, SpaceX, they just built and fired booster 16 in 10 days flat. But here's what nobody's talking about. While Boeing struggles with one spacecraft, SpaceX is building something called GigaBays, massive factories designed to pump out thousands of Starships annually. We're talking about 36 rocket prototypes per facility, multiple facilities per site. How is this even possible? How does one company move this fast while the entire aerospace industry crawls at a snail's pace? The answer will shock you. Because SpaceX isn't just building rockets faster, they're completely rewriting the rules of manufacturing. And it's happening right now. Let's dive right in. SpaceX manufacturing revolution, the speed that broke physics. Here's the reality check that will blow your mind. 10 days, that's how long it took SpaceX to roll booster 16 to the pad. And static fire it after flight 9. Boeing Starliner, still sitting there after 365 days of engineering reviews. But this isn't just about one rocket. This is about a manufacturing philosophy that's completely alien to traditional aerospace. While Boeing engineers are still debating thruster configurations from last year's flight, SpaceX has already moved 3 boosters through their production pipeline. Think about this. Booster 15-1 flew on Flight 8 and is now parked in GigaBay 1. Booster 17 sits in what they call the Rocket Garden, which sounds peaceful until you realize it's actually a parking lot for rockets waiting their turn to launch. And Booster 18? It's already 19 ring segments deep into construction. But here's where it gets crazy. SpaceX isn't just building rockets fast, they're building an entirely new way to build rockets. The GigaBay revolution. Remember Tesla's Gigafactory? That massive battery plant that everyone said was impossible? Well, SpaceX just said, hold my beer, and started building something they call a GigaBay. This isn't just a bigger warehouse. We're talking about a facility designed to house 36 complete rocket prototypes simultaneously. Think about that number for a second. NASA has built maybe 20 rockets total in the past decade. SpaceX wants to park 36 in one building. But here's the twist nobody saw coming. They're not building just one GigaBay. They're planning multiple GigaBays at single sites. The math is staggering. If each bay holds 36 prototypes, 3 bays would mean 108 rockets in various stages of completion at any given time. Why would they need so many? Because SpaceX isn't thinking in terms of launches per year. They're thinking in terms of launches per day. The Florida Gambit. While everyone was focused on Starbase, SpaceX quietly secured something that changes everything. SLC-37 in Florida. This isn't just another launch pad. It's 3 times the size of their current Starship facility. But here's where the story takes a wild turn. The environmental impact statement doesn't just mention 2 launch towers. It mentions the possibility of 4 towers at a single site, 4 catch towers, 4 launch pads, all operating simultaneously. Can you picture what that means? Dual Starship launches within minutes of each other, followed by synchronized landings. We're talking about 18 sonic booms in a single launch sequence. It sounds like science fiction, but the paperwork is already filed. But why separate launch and catch towers? This is where SpaceX's strategy gets brilliant. The heat shield problem. Elon Musk admitted something crucial in his last Mars update. The heat shield is extraordinarily difficult to perfect. Here's his exact words. It is within the realm of physics to get this done. Just an extraordinarily difficult thing to get done. This creates a manufacturing bottleneck. While boosters can be rapidly reused, ships need extensive refurbishment between flights. So SpaceX came up with a solution that's pure genius. Picture this. A Starship launches. The booster returns to the launch tower for immediate reuse with a fresh ship. Meanwhile, the original ship lands on a separate catch tower, gets transported back for refurbishment, while the booster is already preparing for its next flight. It's like having 2 assembly lines running in parallel. One for rapid booster turnaround, another for ship refurbishment. This isn't just efficiency, this is manufacturing warfare. The Block 3 breakthrough. Here's something that should terrify every other aerospace company. SpaceX is already building Block 3 boosters, while they're still testing Block 2. Booster 18 represents a completely new generation of hardware, and it's already 53% complete. The sapien what makes Block 3 different. The still protect we're seeing new ring segments, the Scienceman updated structures, and manufacturing techniques that didn't exist 6 months ago. SpaceX is essentially redesigning their rocket while flying it. This creates a terrifying competitive advantage. While Boeing is still trying to fix problems from 2024, the Scienceman SpaceX already solving problems from 2026. They're not just ahead, they're accelerating away from the competition. The production math that changes everything. Let's talk numbers that will make your head spin. SpaceX's goal isn't hundreds of Starships, it's thousands per year. That means they need to produce roughly 3 complete rockets every single day. Traditional aerospace manufacturing takes 18 to 24 months per vehicle. SpaceX is targeting 18 to 24 hours per major component. That's not just a 100x improvement, it's a complete reimagining of how rockets get built. But here's the question that keeps aerospace executives awake at night. How do you compete with a company that treats rockets like Toyota treats cars? The answer is, you probably can't. The ripple effect. This manufacturing revolution isn't happening in isolation. Blue Origin's New Glenn is targeting its second flight in August, desperately trying to prove they can recover boosters. Meanwhile, Starliner remains grounded with no clear timeline for return to flight. The gap isn't just widening, it's becoming a chasm. SpaceX is operating on a 3-4 week launch cadence, while their competitors measure progress in years. By the time Boeing fixes Starliner's thruster issues, SpaceX will have launched 50 more missions. But here's the scary part for traditional aerospace. This is just the beginning. The domino effect. Every rocket SpaceX builds teaches them something new. Every landing provides data for the next iteration. Every manufacturing process gets refined and accelerated. They're not just building rockets, they're building the knowledge base to build rockets faster. This creates a feedback loop that traditional aerospace can't match. While Boeing engineers debate design changes in committee meetings, SpaceX engineers are already testing the next version. It's like bringing a machine gun to a knife fight. The question isn't whether SpaceX will revolutionize space manufacturing. It's already research. The question is whether anyone else can survive what's coming next. The acceleration trap. Here's what's really happening and why it's so devastating for competitors. SpaceX isn't just building rockets faster. They're building their ability to build rockets faster. Every iteration teaches them something new about manufacturing. Every failure becomes a lesson that prevents 10 future failures. While Boeing spent a year trying to fix one spacecraft, SpaceX flew 9 missions, built dozens of rockets, and revolutionized 3 different manufacturing processes. This isn't just about speed, it's about learning speed. And once you fall behind in learning speed, you never catch up. The 1,000-ship vision. Here's the terrifying truth that no one wants to admit. SpaceX's plan to build thousands of Starships isn't just possible, it's inevitable. When you can build rockets in days instead of years, when you can test designs in weeks instead of decades, when you can iterate faster than your competitors can plan, the math becomes simple. SpaceX isn't just building rockets. They're building the industrial capacity to make space travel as common as air travel. And they're not waiting for permission. They're not waiting for competitors to catch up. They're not even waiting for the market to be ready. They're building the future of space manufacturing right now, whether the aerospace industry likes it or not.